Hey guys, Sonny again. I'm going to talk to you a little bit about this X-ray. We posted a picture of this on Moodle last week, and I told you we would talk about it. I also gave you a little assignment to try to identify the component parts of this X-ray tube. If you have done that, great. If you haven't, well, here's your answers to that question or that assignment. First of all, the X-ray tube is a relatively small piece of the X-ray machine. I think we made a point last week that the X-ray machine itself really takes up about a whole room of equipment. So this is a relatively small piece of that. It's I don't know, maybe the size of a couple, 2 or 3 shoe boxes. So it's not huge, but it's it's very important. As a matter of fact, it's the most important part of the X-ray machine. This is where the X-ray energy is actually produced from electricity we feed to it. So let's talk about it just a little bit. A couple things to point out. First of all, I think we made the mention last week or in the previous video that there's about 150,000 volts of DC energy across this thing, about negative 75,000 on one end, a positive 75,000 on the other. So this is actually going to get the energy to create these X-rays, but it needs some other things to go along with it too. It's actually a fairly simple device. First of all, point out to you that it is all enclosed, as you see here, in glass. This entire thing is a glass envelope, and there is a motor attached to it. The motor actually turns this stator in the middle of it here, the stem, and rotates this piece of equipment right here called the anode. It's a very important piece of this X-ray tube. This whole glass envelope assembly is then suspended inside of a metal enclosure. And if you've ever had an X-ray taken, that thing that they grab a hold of and they pull down over you, it's sort of circular in shape. That is the X-ray housing. That is the tube housing. It's metal, and this glass envelope is inside of that. And between the glass envelope and that metal casing is oil. It's dielectric oil, and it's there simply to help this cool off because this is a very hot piece of equipment. It develops a lot of heat in there. So more about that a little bit later. But right now, this is a glass envelope, and inside of it we have this motor, a rotating anode, and we have a window right here. You can't maybe not see this, but this is a glass window. The rest of this is covered inside with some metallic substance that keeps energy from going out that way. So we actually direct the X-ray energy out this window. Otherwise, it should all be contained inside there. Another important element is this cathode right here, or a filament. What we're going to do is we're going to provide 2 sources of electricity to this X-ray tube. One is going to be this high voltage of 150,000 volts. Another is going to be a relatively low voltage applied to this cathode or this filament. And the purpose for that is actually to provide a current that will boil electrons off of the filament of that cathode. It's really no different than if you've got any old incandescent bulbs, light bulbs in your house. It reacts the same way. Those incandescent bulbs, we flow current through there. They boil electrons off, and that imparts additional energy into the electrons. And then when they fall back to where they came from, they release that energy in the form of light. We do a similar thing with this X-ray tube right here. We flow current through this filament, and it boils the electrons off just like the electrons in the filament in your light bulb. The only difference is after we boil those electrons off, we encourage them to sort of hang around this filament in a cloud. We call it a cloud of electrons. So what we want to do is we actually want them to impact this rotating anode, this anode that we see down here. And I didn't point this out either earlier. It's actually a bowl shape. You can see it angles down here and here. And if you can imagine that going 360 degrees, it's sort of an inverted bowl. And this thing rotates. And what we want to do is we want to take these electrons that we boil off of here, and maybe I can simulate that with this, and have them actually impact this anode down here. We do that with this high voltage. You know, electrons have a small negative charge. we apply a negative 75,000 volts up here. These electrons that boil off on here have no interest in going back this direction because that's a like charge. And we know they're going to be repelled by this negative charge up here, but they're going to be attracted to this positive 75,000 volts down here. So as these negatively charged electrons boil off, they're going to zip down in this direction. They're really trying to get all the way down here to this negative 75,000 volts, but there's something in the way. What's in the way is this anode here, and in fact there's a specific piece of this anode called the target, which we see right here, which also rotates around. Those electrons will impact that target, and as they do, as high-speed electrons impact that target, they're going to create X-ray. That X-ray energy will be produced when these electrons impact this target, and they will be emitted at an angle just like this. So we send electricity in here, we send electricity here and here. We cause the electrons to boil off of this, impact this, and X-rays are then emitted out of this window. How those X-rays are actually created when the electrons interact with this anode is what we're going to talk about in the next video. But for right now, take a look at this and try to get this in your head. It's not very difficult. This is where all X-ray tubes work, whether it's just taking an X-ray image, a single image, or if it's part of a CT scanner, which uses one of these, a very expensive one of these, but it works on the same principle. It just emits X-rays out of the window by this impact that we saw earlier from the electrons. So keep that in mind. Take a look at that. Get out your book, take a look at that, study on that, get that in your head, because we're going to talk a lot about the interactions that take place right here inside this anode. That's where all of the X-ray energy is actually produced. Okay, more in just a little bit.